Okay, welcome to Chapter 1, Lesson 7, Compute with Scientific Notation. Our learning target or objective for this lesson is to compute with numbers written in scientific notation. And yay, no vocabulary words for this lesson. So we're going to get right into some examples. Okay, as our objective is computing with numbers with written in scientific notation. As you see, we have 7.2 times 10 to the third in parentheses and 1.6 times 10 to the fourth in parentheses. We have two parentheses next to each other like that. That means you are multiplying. Here's what we do when we have scientific notation in the parentheses. We're multiplying. We're going to take them out. We have 7.2. We're going to multiply it times 1.6 by itself. And then we have 10 to the third times 10 to the fourth. All you're going to do is going to multiply 7.2 times 1.6, and you're going to get 11.52. And then when we have bases of the same, we treat that the same. We have 10 to the third times 10 to the fourth. Our 10 stays the same. And what do we do with our factors? We just add them. 3 plus 4 is 7. So now we have 11.52 times 10 to the seventh. Is that our answer? No, it's not our answer, because in scientific notation, we just learned in previous lesson, we can only have one number to the left of the decimal, and we have 2. So what we need to do is we need to move the decimal spot one spot over to the left. This number becomes 1.152 times 10. It is not 7, because this number got smaller. It became a 1.1. This number went down. That means this number goes up. Now it becomes 10 to the 8th power. Okay, moving on. Our next one is an addition problem. 6.89 times 10 to the fourth plus 9.25 times 10 to the fifth. Here's not as simple. We can't just pull them out and add them together. We have to make sure our factors are the same number. So we either have to make one a 5 or the other one a 4. And let's bump up. Let's make our 9.24 times 10 to the fifth a 4. Okay, so our first one, 6.89 times 10 to the fourth, that all stays the same. Now this one, we're going to make this a 4, so this number is going to go down. So that means this number goes up. When this number goes up, we move the decimal to the right. So now this becomes 92.4 times 10 to the fourth power. And now here's all we need to do. We just need to add our first digits up here. Get 92.4, 6.89. I'm going to put a 9. Yep, 99.29 times 10 to the fourth. And is that our answer? No, it is not, because once again we have two numbers to the left of the decimal. So we need to move this over 1. This number went down. This number goes up. So now it became 9.29 times 10 to the fifth power. Now if you would have changed the 4 up at the top, if you would have changed this to a 5, you still would have ended up with this answer at the end of the problem, regardless. Okay, once again, any questions, please review the video, write down any questions that you may have, as we will be going over examples in class. And our last one, we have 7.83 times 10 to the 8th minus 11,610,000. Okay, first of all, we need to make this 11 million scientific notation. So first we'll rewrite this, 7.83 times 10 to the 8th minus, make the scientific notation. Remember, there's a decimal always there. 1, 2, 3, 4, 5, 7 spots. Remember, you have to write every number to the right of the decimal until you get to your zeros. Then you can stop writing. So now we have 1.161 times 10 to the 7th. Just like addition, we need to change the factors so that they are the same. It's 8 and 7. We have to change. So we're going to drop this 8 down to a 7 this time. So this number goes down. It means this number goes up. This number gets larger. It means we go to the right. So now it becomes a 78. 3 times 10 to the 7th minus 1.161 10 to the 7th. We subtract those out, we get 77.139 times 10 to the 7th. And we are done. No, we're not done, because once again, always check your scientific notation. Make sure there's only one number to the left of the decimal. We have 2, so that means we have to move our decimal over one spot. 77 becomes 7.7, so this one goes down. It means the 7 goes up. And now we have 7.7139 times 10 to the 8th power. Now we are done with that problem. Again, any questions, please write them down, review the video, bring them into class, as we're going to head over to our real world example. In 2010, the world population was about 6,860,000,000. Population in the United States was about 3 times 10 to the 8th. But how many times larger is the world population than the population of the United States? Oh. So we're going to estimate, we're going to change the 6 billion, we're going to estimate it, we're going to bump it up to 7 billion. But we're going to write in scientific notation. So first of all, if we're going to change this, okay, first you estimate it. About, when you see about, that's about estimating. Okay, now we're going to change it to scientific notation. Remember, there's always a decimal there. So 2, 3, 4, 5, 6, 7, 9. So the world population is 7 times 10 to the 9th power. And the United States is 3 times 10 to the 8th. We are going to divide, you divide them. 10 to the 8th. So when we have a division problem, all we do is we separate them out again. We're going to take 7 divided by 3, which gives us about 2.3. And then what do we do when we have the bases are the same and we're dividing with our factors? We subtract them. 9 minus 8 is 1 times 10 to the 1st power. And if we're estimating, we can always write this little wavy sign in front. That's about. So the times larger is about 2.3 times 10 to the 1st larger than the population of the United States. Okay, any questions? So again, please write them down, review the video, as we will go over many examples in class.